I just have one question. Are you able to give me a blank sheet of this and then, okay, okay.
Find my. Mm. You can grab a scratch sheet though.
Okay. It's right here, fine.
Yeah, that's great. Thanks. Okay, so questions about LCT. If I see like a rational function, bunch of n's, that's usually a good indication that it's probably going to be a good fit for LCT. So like nq plus. Something like this. Well, first, your nth term tests would be inconclusive. You wouldn't be able to get any result out of that. But next thing is looking at the degrees. And if we were to strip away I focus on the highest degrees, you're going to get n cubed over n to the fifth. And that relationship here is going to allow us to see that there is a comparison partner of 1 over n squared, right? Strip away the 3, and then reduce that n cubed over n to the fifth all the way down to 1 over n squared. And we know 1 over n squared is a converging p-series. Right, so if we can get limit comparison to test to be valid, then we know these two must share the same behavior, that these two both will be converging. Yeah, so then you're gonna go through dividing these two. Doesn't matter which order, it could be this over this or this over this.
Okay, is it like over 1?
Hmm?
Like when you divide them or like multiply by the
Reciprocal, yeah.
Like what's the condition that would hit?
Right, the condition is that's got to be a positive finite number. So if it ends up being like 2/3 or 8/5, then you know that, okay, it's valid. But if it goes to infinity, then it's not a good test. We should do something else. But typically, when we get to this point, we already know this is going to be a pretty good test. This is going to be a good fit because it has that LCT feel about it. Three is a finite number, and because we're getting a positive finite number, we know that these two will share the same behavior. So we can say that our series will converge by LCT. Did I give you the worksheet from yesterday?
Yeah.
Okay. Hey, if you're joining me online, let me know if you have any questions that you want to go over, either from worksheets 1, 2, and 3, or from the review that I sent out last night. And if you picked it up in third period, I've got to give it to second period.
Are you able to go over a direct comparison test?
Oh, sorry, Harrison, say it again.
Can you hear me?
Yeah.
I said, would you be able to go over direct comparison test?
Yeah.
Thank you.
So direct comparison tests are really for kind of like a last resort where nothing really fits in terms of, it's maybe not quite good for limit comparison because what do we do with that cosine n over 2? So direct comparison is kind of like something where you can kind of see there's a relationship, but maybe there's different families of functions that's making it kind of clunky. But for this problem here, cosine n over 2, first off, we know cosine is just going to kind of fluctuate between -1 and 1, right? So, all right, cosine n over 2 kind of does the same thing. It's just kind of fluctuating between those values, right? Maybe something like variations of this, but it's just kind of doing this, right? So if we know that this is kind of basically 1-ish or -1-ish, it's not moving a lot. It's not getting large. It's not getting small. It's, it's kind of oscillating, but it's oscillating in a very, very small window. But so I think the larger relationship here is if this is basically quote unquote one, and my highest degree is n squared, then maybe I can compare with 1 over n squared, right? That seems to be the part of the problem that's having the most impact, right? That 4n is not having much impact. That cosine is, again, it's just -1 and 1. So what do you know about 1 over n squared? We know 1 over n squared is converges, right, by p series. So direct comparison would be if we can show that this is less than a series that converges. Max. And because my denominator is growing at a faster rate than this denominator, if something in the denominator is getting larger, the overall fraction is getting smaller. So therefore, this is a good fit, right? I have a converging series. Anything smaller than the converging series must also converge as well. And this ultimately is not going to make much of a difference because between -1 and 1, if this is like down to like, a billion, right? That -1 and 1 is basically going to be just a very insignificant part of this relationship here. So we can say this converges by DCT.
How would you know to do a direct comparison test over alternating series test? Because of like the cosine, the numerator.
Well, this cosine n over 2 is not. Got it. Okay. I see what you're saying here. Because this doesn't involve pi, so this isn't going to be a nice clean -1, +1, -1, +1. It's, it may be positive for a little bit, and then it goes back to negative for a little bit. It's not quite, the only time you're going to get a nice clean -1, +1, -1, +1 is if like pi is involved, like cosine of n pi, or sine of n pi over 2. But if it's just n over 2, it's not going to oscillate as cleanly between positive and negative.
Okay, thank you.
Mm-hmm. Okay, Max, questions? Do you get a chance to work through the worksheets? Okay.
Just right here.
Yeah, I'll go through that.
How much? Because on the key, like there was a lot of work shown. Couldn't you just look at it? Because none of these would make a negative number here, which means it wouldn't be an alternator, right? Are there other ways to that would make it conditionally convergent?
No, you're right. Yeah, if I plug -3 in, that would
Okay.
make it right. But I just want to show that we can also go through ratio test and test the endpoints as well.
Okay.
Yeah.
So it's not necessary to do?
It's not necessary for this problem, but for something that's related, it may, if I ask you for a range where all the range of all the terms when the series is converging, then we need to go through ratio tests and actually test the inputs. Okay, questions?
Oh yeah, so for AST, do you just like confirm that the limit equals 0 and then that was the absolute value of like a n plus 1?
Yeah, so if it's AST, then like this one here, you would list out your two conditions. That the limit as n approaches infinity of 1 over n does equal to 0, and that your a sub n plus 1 is less than or equal to a sub n. So just write it out. You don't have to show your work for that. But these are the two conditions for AST. So you want to make sure that we list out both of our conditions for AST.
Then you like find, and then for conditional convergence, so that would mean the original series like diverges.
That's right. The original series
The
diverges.
alternator.
That's right. That's right. So this one would be a conditional convergence because without the alternator, it would diverge. But with the alternator, it converges. Meanwhile, something like this would be an absolute convergence because it doesn't need the alternator to converge. You can strip away the alternator and it'll still converge by P series.
Always converge with the alternator or like.
No. So for instance, let's say I had this. -1 to the n times n over root n. Limit as n approaches infinity of n over root n would be what?
That would be n to the power of 1/2.
Mm-hmm.
So. Diverges.
Diverges, goes to infinity.
Yeah.
So if it diverges, that's obviously not equal to 0. And because of that, it doesn't fulfill this condition. And so if this happens, we don't say it diverges by AST, we say it diverges by nth term.
So
So
that's
this,
all you have to do for AST, like
Mhm.
conditions.
Yeah, AST should be, as long as there's an alternator and you can get that to be true, this will follow suit. You just have to state those two things. So with AST, there's three things. You can have conditional convergence. If I ask you just for convergence, then you don't have to say conditional convergence. You can just say that, okay, this converges by AST. This also converges by AST. But if I asked you to break it down, then this is conditional convergence. This is absolute convergence. And this, even though you're kind of going through alternating series test, it doesn't equal to 0, but then your reasoning would have to be diverges by nth term. Yeah, absolute value symbols around your a sub n plus 1 over a sub n. Yeah.
Okay. Time like a sub n is like sine of n is cosine of n, does it always diverge? Like if it's just like sine of n?
If it's just sine of n, then just know that it fluctuates between -1 and 1, and a lot of times it may not mean much in the overall scheme of things, especially if you have like n cubed and n squared, that's really taking over the large behavior of the problem. So it's kind of like just like one-ish. It's oscillating, but it has a very minimal impact.
for number 22.
Oh, 22.
Like on the key, it had like, it showed like you plugged in n equals 1.
Yes, right, because this kind of looks like an alternator. So to prove that this is not an alternator, you would have to plug in 1, 2, 3, 4 and show that the numbers are not, going between negative and positive. Right.
Okay.
If it's positive, positive, then negative, negative, that's not good enough for alternator. Or if it's all positive, or if it's all negative. Yeah, so it's kind of like, okay, this looks like it could be an alternator, but we want to kind of test, 3, 4, 5 consecutive terms to see if it's actually behaving the way we would expect it to behave.
Page 13. Question 16. It's like we also be minimize negative things.
Hey, page what?
13, number 16. So like on the key, the ampersand 3 is less than C is less than 4. But could it like P also be negative, or can you not do like if it was like negative less than -6 or something? Because then like it would feel like
Less than 4. Less than -6. I think you're right. I think the problem is it should have been phrased what positive values of P. But without that being said, then you could say P is less than -6 and you wouldn't lose any points because the direction is not clear enough. But I think the problem is meant to be for positive P values. But you're right.
So that's just like you find the root of n, and then if it's under 1, it's converting.
Yeah. So you can spot root test because the whole thing can be raised to the nth power. And root test is if I can take the nth root of a sub n, meaning I can strip away that exponent, I can just focus my attention on what's inside the parentheses. And if I can show that's greater than 1, then it converges. Equals to 1 would be, oops, sorry. Yeah. Yeah, equal to 1 would be inconclusive, and greater than 1 would be diverging. So this is greater than 1, so this will be diverging.
What's the nth partial sum? Do we just want the limit of it for the sum? Like for on page 4, like number 14. Like for those like
Page 4. Let me see.
do we always find the limit? Because like for that question.
Exactly, yeah. The sum of the series is same thing as the limit of the partial sum. Yeah. Right, yeah.
This ratio.
Yeah, so I'll leave that up on the board there, parting C. So P is for what? P series, A is for IST, R, there's two R's. Rate and ratio, yeah, ratio and root, I,
Is there telescoping too? Or like, is that,
yeah, that's T.
oh, okay.
Yeah, sorry, my bad. T is telescoping, I is integral, yeah,
And then
G is
GST,
GST, and C is
both the comparison.
both the comparisons, direct and limit comparison. Those are all the tests.
AST was
Was this. There's an alternator, and there's two conditions.
You just remove any testing conditions. That's AST.
That's it, that's AST now. And they can either be zero or not zero. If it's not zero, though, you have to call it nth term diversion.
When the root tested, you just take the root
Mhm.
and solve it.
And then compare with one, either greater than one, less than one, or equal to one.
Then ratio test, and you plug it into that formula.
Absolute value of a sub n plus one over a sub n.
So for alternating series test, so to figure out if it's diverging, like, so if it's diverging in like any case, it'll diverge by n term.
That's right.
Okay, so you'll just find that out when you do the limit of.
Exactly, right. So basically, I mean, when you do the limit of a sub n, you're kind of doing both conditions for AST and for nth term. It's just, based off the result, you have to call it one thing or the other. If it's equal to zero, AST. If it's not equal to zero, it's nth term.
Okay, so. And then, okay, so going back to like conditional conversions, like, do you have to write out that the limit with the alternator is like converging, or like how would you do that? Like if you have to do it with the alternator, like is it just?
Let's say I ask question, is this series, can you prove that this series has conditional convergence? You would say that this converges by AST. However, the limit of n approaches infinity of 1 over n. The absolute value of a sub n is equal to 1 over n, which diverges by p series. So you just have to indicate that the positive version of the series diverges. But with the alternator, it converges. Then it'll be a conditional convergence.
If we see an alternator, we just have to do AST.
Yeah.
Or ratio. This ratio test is absolute value, so one becomes.
Right, but if you see an alternator, you should consider AST. It wouldn't be a ratio test. Ratio test has absolute value in it, but the absolute value is to see if that absolute value of that expression is less than 1, equal to 1, or greater than 1. We don't want to get the negatives involved, but ratio test should be easy to spot. Right, anything with factorial, anything with anything with factorial or exponential functions typically is a good fit for ratio test.
So whenever you can do GST ratio.
Whenever you GST, well, GST should be easy to spot. You know, you're right, you're right. GST has a similar look to ratio test. Like this would be GST, right? But basically, if you see any factorials in it, or if you see something where it doesn't quite fit into ratio test like this, if you include that n in here, then this will turn into a ratio test because it doesn't fit into a nice geometric series.
It's A B plus one. A of B plus one plus one.
You mean ratio test?
Yeah. A n plus
A sub n plus one divided by a sub n, and see if it's less than one, greater than one, or equal to one. Okay, sorry, Max. Do you have a question?
Oh, yeah. Yeah, what are other common alternatives besides like -1 divided cosine? Is there anything else?
No, those are the only ones. So -1 to the n, you have sine of pi over 2, and then you have n pi over 2 and cosine of n pi. Those are the only ones that we have to worry about.
And what about, and also like n plus one on the first one?
Oh, right, that's right, you're right, yeah. So you can have alternator that starts with n plus 1 or n minus 1, so any versions of that would be alternator.
And then if two of them are together, then that just doesn't qualify for
You have to test it. You have to kind of
like.
right, go through it because it's like, oh wait, are they canceling each other out or is this still an alternator? Like, yeah, a lot of times we don't know. We have to kind of, if we see two different things that could be opposing each other, we have to just run through a test. And
Do we need to find the sums for like, because I know we had to for GST last.
yes, GST and telescoping.
Okay, so it's still the same too.
That's right. Still the same too. Yeah, we can't find sums for the other ones.
So direct and limit comparison is just when I take like a similar function.
Yeah, so
Is that one?
I would say, yeah, limit comparison would have a certain look to it where, you know, everything is kind of like a rational function sort of. And obviously you want to go through nth term tests first. If nth term test doesn't work and you see, okay, this is equal to 0, okay, maybe I'll go to limit comparison test now. And limit comparison test, strip away everything and look at just the highest degrees or the most impertinent relationships. And once you get that relationship, decide whether it's converging or diverging, and then go through the limits of one over the other. It doesn't matter which one I divide over each other. I typically just do the one in question divided by the comparison partner. And as long as I get a finite positive number, then I know that these two series will share the same behavior. Yeah, that'll be nth term. So if I had like the relationship is L R P E. I guess we can add F for factorial. Logs is slowest, followed by radical, followed by polynomial, followed by exponential, followed by factorial. If I have a faster growing one over a slower growing one, that's an easy problem. We can just say diverges by nth term. If I have a slower growing one over a faster growing one, then nth term is not going to be a good fit. We have to look at maybe another test.
It's factorial.
Factorial is the fastest. Or it's like n factorial would grow faster than 2 to the n. Yeah.
So like the only other case you wouldn't use ratio test for factorial would be is if it's in like the numerator and it's growing faster.
Right. Exactly. Right. Because I mean, you can still do ratio tests, but nth term will be a lot faster. Right. Or if you see something like this, maybe it's a good idea to start breaking everything apart, start canceling stuff out and see what's left over and see if nth term will take care of it.
How do you break it apart? If that'll be.
Yeah, so I'll show you an example. Let's say I had this, right? Then this would be n plus 3, n plus 2, n plus 1. And I would stop at n factorial because I see an n factorial in the denominator that I can cancel out. So this cancels out. But this is still obviously higher than denominator. This would go to infinity. This would be nth term divergent.
You said for alternating series, that if it diverges,
You say nth term test.
it can also diverge with P series. What is that?
If the limit doesn't equal to 0, then it's going to be nth term.
If it does converge, you say converges by alternate.
That's right. Oh, speaking about P series, let's say I had this. What is this here? Right, this is not P series because p-value has to be a positive number in the denominator greater than 0, right? And this looks like, oh, this looks like a p-value of -1/2. It's not. This is really 5n to the 1/2, and this is really an nth term test that goes to infinity, diverges by nth term. We wouldn't say that it diverges by B series, right? It doesn't fit that category. P has to be has to be a positive number greater than 0.
Like something like 5 to the 1/n, like either in the numerator or denominator, because that's like the opposite, or like in the exponent, like 5 to like a fraction.
Like that?
Yeah, with like n in like the denominator, because that doesn't follow like regular
Oh, 5 to n over 2 like that?
or
Or 5 to the 1/2 over n?
if like the n was in the bottom of the fraction.
Yeah, write it out and I'll see what you.
Is it to the power 1/n?
Yeah.
Oh, right. Okay. Yeah, that's strange.
Could you do integral test?
Right. Yeah. Like if I have that, I would maybe fit it more like into this. And make it where, okay, it's gonna be more like an integral test.
Okay, would you wanna like change that to like negative, like n to the -1 and move that to the denominator, or is that like?
No, well, because if you're going through u substitution, the entire exponent has to be the u value. So you can say u equals 1/n, and then you can get it ready for power rule to find the derivative.
Okay, because that's just like the opposite of like the growth rate thing.
Yeah, you're right. You're right. This doesn't quite fit into a growth rate. Yeah, e to the 1/x is not the same thing as e to the x. Yeah, this is not going to grow the same way that e to the x will grow.
Like name breaks. Without the abbreviation.
Oh, ASD.
Yeah,
Oh yeah, alternating series.
that one is just we or get that. Less than.
Oh, for alternating series? No, you just do the limit as n approaches infinity. Yeah. Just that.
When does it converge and diverge for ratio test?
If the absolute value of the a sub n plus 1 over a sub n is less than 1 or greater than 1. Like that. Okay, here we go. Yeah, if this relationship is less than 1, time converges. If it's greater than 1, it diverges. If it's equal to 1, it's not a good test. We should be looking at something else.
What test three? That's
It depends, yeah. Typically, I think we're good enough where we can kind of look at a problem and tell that it could be a good fit for ratio test. I mean, I guess if we're looking at something that should be for integral tests and you're doing ratio tests, it's like doesn't quite fit. It's like, oh, okay, we should look at it more carefully and see maybe there's a better starting point. But hopefully we're at a point where we can kind of look at a series and kind of have an idea. Okay, I can at least narrow it down to maybe 2 or 3 tests, and I'm not going to think about every single test if I look at a problem. There's certain characteristics of these series.
If you go back to the AST, so for AST, all I have to do is
Well, first off, identify there's an alternator, and then just look at the positive version of the series and see if it's equal to 0. If it's equal to 0, then it'll converge.
then the second one is
You just have to just state it out. This is one of the conditions. I mean, if it passes the first one, for our purposes, it'll pass the second one.
that's the one that's like well, limited.
This just means that every term needs to become less.
Yeah.
Or the absolute value needs to become less. It can't be like greater than and then less than. It can't be like oscillating. But the ones I give you, it's not going to pass the first one and fail the second. But it's a condition, so we have to make sure we state it out.
So if you're doing direct comparison, like I know it's like the last one, but like if you're doing that and it just doesn't follow like the end thing, like it's bigger,
Yeah.
if it diverges or smaller. if it
Yeah,
converges.
it's not a good test. We should be, yeah, okay, I've got a good instance of that. Let's say if it was this problem here, right? Let's say I try to fit into this relationship, right? 1 over n squared is converging. Thank you.
Retake.
Yeah, you want to do that?
I can do that now.
No, okay. Okay.
That'll be n over n squared, because there's technically an n and a cosine.
Well, cosine n over 2 is really like cosine of n, which just oscillates between -1 and 1. So it's basically like it doesn't really mean anything. It's just like a -1 to 1. So you see how this is not a good relationship here because this is smaller, which is overall larger, right? This is not going to good fit. So if you can't quite get direct comparison to work out, maybe you can pick a better comparison partner that is for sure greater. So what if I had 1 over n cubed? Here, it doesn't matter that we're talking about that we're subtracting 4n. This n squared is clearly something is larger in the denominator. That means it's smaller overall. So this is small. Oh, sorry, my bad. Let's say I had this instead of n cubed. What if I had so this will converge. This is smaller in the denominator, which means this is smaller in the denominator, which means it's larger overall. This is larger in the denominator, which is smaller overall. So this is a better fit. Again, DCT is like it's like if it doesn't quite fit, you may have to find something that will allow the relationship to match a little bit better. But again, it's like last case scenario because it is so like clunky, right? It's like it doesn't, you kind of have to look at everything and kind of set it up.
So for DCT, we can just change the comparison partner.
Yeah, change comparison partner. As long as you know what your comparison partner is and you can get a clean relationship, then DCT can pass. So sometimes if you feel like, oh, I'm stuck with this n squared, maybe I can find another comparison partner that I know for sure will converge and larger than what I'm comparing with.
Oh, so the only bound is that it has to be larger.
It has to be larger.
And
Yeah,
if it's diverging, it has to be small.
right. I know it's not a fun one to do, but you're only doing it if your series doesn't quite fit into that limit comparison test.
But if it's n squared like the original problem?
Hmm?
If it's n squared like the original problem, it would still work.
This one would not work because here you see how this is smaller than this one. That means this is overall larger. So this would be a good fit if this was diverging. Then we can say this might also diverge as well.
So for AST, all we're doing is we're removing, it's whenever we say on alternating, we remove it and we test with the conditions. So we don't have to like use any other tests, we just test the conditions and
It should be an easy test. Alternating series test should be an easy test.
and how do you tell the difference between conditional and absolute?
Let's say I strip away the -1 to the n. I'm left with 1 over n. What do you know about 1 over n? Diverges, right? So with the alternator, it converges, but without the alternator, it diverges. So we call that a conditional convergence.
And absolute is with the alternator.
Absolute convergence would be if would be something that does converge with the alternator and without the alternator. So like this one here, we know this converges by AST, but this can also converge without the alternator because it passes the p-series test. So this would be absolute convergence because this series does not need the alternator to make it convergent. Meanwhile, this series does need the alternator to make it convergent.
How does that one pass?
If p is greater than 1, my series will converge. Like p, like n cubed, n to the 4th, n to the 5th.
If p is equal to 1, it also diverges.
That's right. It's harmonic series, right? 1 over n, right? 1 over n would be harmonic series.
If we find an alternating harmonic series, do we have to do all the conditions on the side or the same?
Yeah, I'm looking for this. I want to see that you're stating your both conditions for AST, even though we know this is going to pass. If it passes the first one, it'll pass the second one, but this is the condition, so I want you to state it. Just like with integral tests, right? The positive, continuous, decreasing, you're not really testing it. You're just writing it out as justification.
All the conditions, like only for like this and integral tests that we would have to state conditions for.
That's right. But also I saw on the quiz where students would say nth term, but they wouldn't state what they were doing. You're applying the limit as an approach infinity of a sub n, and you're showing that your result doesn't equal to 0. So I'm looking for those statements as well in your nth term test, that you're just stating what you're doing and how are you coming to your conclusion. But you're right. In terms of like actually stating like specific preconditions, it's just AST and integral test. And the other should just be, what you've been working on.
For root test, once you take out the n, are you just comparing degrees?
For root test?
Yeah. So that when you do root test, you get like a 2n squared or and Q.
Essentially, yes. Let's say I have one over n over e. Sorry. So if everything is raised to the nth power, then that's a good indication that's going to be a root test. Then you take the nth root and you just look at what's inside the expression and see if that is greater than 1, equal to 1, or less than 1. If it's greater than 1, then it diverges by root test. If it's less than 1, it converges by root test. This would goes to infinity, so this one would diverge.
If it is equal to 1, we use a different.
Yeah, it's different one.
So like all the one, this is like a weird question, but like for all the ones where you're like comparing with one, like your limit or like your result, is P series the only one that ends up converging if it's higher than 1? All the others is converging if it's less than 1.
Yeah, that's true. Yeah, geometric series is less than 1. Ratio test is less than 1. Root is less than 1. Yeah, you're right. But just make sure, if you're doing P series, that it needs to be in the right place. It needs to be in the denominator and it needs to be a positive exponent. Yeah.
And then
Yeah. Well, and then P series will diverge if your P is between 0 and 1. Right. Between 0 and 1.
so like and then for all of them, if it's equal to 1, it diverges. Like not, or some of them it's like incomplete. So
Yeah. P series diverges when it's equal to 1, but a lot of the other tests are when it's equal to 1. Well, just ratio and root will be inconclusive. And a limit comparison test, you're just looking for a positive number to see if it's valid.
Are GST and telescoping series the only one where we have?
They're still the only ones that we can find the sum. The other ones, we don't know how to find the sum.
Can you go over a problem where you're looking for x values to see if the series is conditionally convergent, like 32 in the review packet?
Mm-hmm. This is page 17. So anytime you see something that is in this form here, we're going to step through ratio test. So here's my a sub n divided by, a sub n plus 1 divided by a sub n, which is multiplied by the reciprocal. Okay, we'll go through a series of cleanup, see what happens. N is the only one that's moving. So if it's n over n plus 1, that'll go to 1. So the only thing left is going to be 5x minus 2. So then you take that 5x minus 2, set up your relationship here. But absolute value, if I want to drop the absolute value, I need to make it -1 and 1 on both sides. Then we just want to get x by itself. Divide by 5. So x is converging between 1/5 and 3/5. But it's definitely converging between the two, but it may have issues at 1/5 and 3/5. So we're going to test both to see, is it going to be a conditional convergence or is it going to absolute diverge? So if I plug 1/5 in for x, I get 5 times 1/5 minus 2 to the n. This will give me -2 to the n over n. And this is not going to converge, right? This is a much faster growth relationship than this one. This will go to infinity. So we know that 1/5 is not a good fit. But what if I plugged in 3/5? 5 times 3/5 minus 2 to the n. See. Oh, sorry. My bad, my bad. I thought it was -2. It's 1 minus 2, which is -1. Sorry, my bad. It's -1 to the n. This does conditionally converge. So we know 3/5 will, but sorry, 1/5 will. But 3/5 will give me 1 to the n, which does not converge. It's just a p series. So it's just going to be 1/5. So after you go through ratio test the endpoints with the series and see what's happening.
Why did you set it under one? Like,
Because I'm looking for convergence, right? I'm looking for convergence. And I know that if I have a interval of my convergence, then it's just going to be the endpoints that could be falling under that conditional convergence right at the edge.
so like in every case, you would do have set it under one.
Yeah. If it's ratio test, you're always going to make it less.
Thank you.
So does every test have something we need to use as a person for the week? Or is there
Ratio test means that telescope thing doesn't really yeah, everything does involve.
Can I finish it?
Just chat. Anytime. Mhm. No, the 4 is going to Okay, but if you come back, it'll be a late. That's what
How many points is it? Okay, can I finish this?
Yeah.
In my just. Like I so much work or what? I was like, yeah.
Yeah.
Yes.
say that by the test and turn when you say that when does M like do the variables?
That's nice. Okay, thank you.
Oh, do I have to take one?
I'll take it.
We see you.
It'll be a slight.
Yeah.
Okay. Right.
It's getting like. I go to the doctor for.
Fine.
I mean, you don't finish it. It's just like you I don't know. I'll finish it. I'm TA. I'm taking one before this. It shows the good stuff. I can't say everything yesterday. I would just be.